want you to create a rectangle. And in that rectangle at the top, I want you to write the word hydrogen. Underneath it, you're going to put the number 1. Underneath that, you're going to put a capital H. And underneath that, you're going to go 1.00. And I don't want to screw it up. I think it's 8. Pretty sure it's 8. I don't have a periodic table in front of me. But this is what you would see if you go for a typical periodic table. Now, if you in your book, page 156 to 157, it's a 2-page splash of the periodic table itself. It looks like this. It's got the periodic table with all sorts of wonderful stuff on it. It's a good reference point in your book for the periodic table. As a matter of fact, I'm actually going to put a tab on it just so I can get to the PT if I need it. And if you take a look here, hydrogen it says hydrogen 1, H, and 1.008. And the thing is, we need to know what all of these are. We're not going to worry about states of matter quite yet, but we need to know what these numbers stand for. First off, the easy stuff. Hydrogen, what are we going to call that? Yeah, the element name. So it's the name of the element. So for this guy, we have a name of an element. Now, this one right here, the H, what is that? Yep, the element symbol. So we have our element symbol. So those are two things. Now, for this guy right here, the 1, what are we going to call this? Yes, atomic number. Now, right here, atomic number. It's weird on my screen, it's kind of crooked. On here, it's straight, but if it's straight here, it's crooked there. I'm trying to make things as best as I can. For atomic number, what is the atomic number equal to? I'll give you a hint. It's the number of protons. But it's also equal to something else. The number of electrons. So you get the number of protons and the number of electrons. So for hydrogen in its most stable state, you're going to get 1 electron, 1 proton. Now this guy, what's this guy called? Atomic mass. And this is actually the weighted average of the isotopes of an element. This is an average value. And the idea, we're going to talk about isotopes in a second here, but the idea is that for hydrogen, there's more than one version of hydrogen. And I'm going to show you what that means and how we can figure out what the different versions are. What the average is you take what we call a weighted average. So there's 3 different versions of hydrogen. So maybe one is more present than the other one, and you have to figure out what are the concentrations or the what we call abundance levels. How much of each are there? And then you have to figure out how much each is going to contribute to the actual atomic mass. And that's how we get our average out of that. We're going to calculate that, not today, but on a different day. But that's one thing that we are going to be dealing with. So, what we need to be able to do from this part of it is understand that, all right, we see hydrogen, that's the name. We see the number 1. That's our atomic number, and that's going to tell us what? Yeah, the number of protons and the number of electrons. Remember, the protons have that positive charge. The electrons have the negative charge. What particle does this not mention at all? Neutrons. Now, if I told you about it, we have down here, this is our atomic mass. It's our weighted average of the isotopes, which means we have different versions. Now, let me ask you this. Do you think the number of protons, if we're talking about 3 different versions of hydrogen, are the number of protons going to change? No. Because the number of protons in the atom, or in the nucleus, is going to tell us which element we have. What's the one, and the number of electrons are only going to change when we start building compounds and things like that, when they're reacting with each other. So if I know the protons aren't going to change, the electrons are only going to change if we're going to start adding them to different elements. What's going to change that's going to make these isotopes? The number of neutrons. Exactly right. And that's the next thing that we're going to talk about.